Hi guys, good evening and thanks for joining. So yesterday we completed software development lifecycle versus secure software development lifecycle. So that one we can use it for entire application security. Okay, so let's start for new topic, cryptography. So it's one of the very important topic, not only for the technical point of view, how to learn things, but also for the interview point of view as well. So let's start here. So cryptocurrency is different and cryptography is different. Don't get confusion here and there. Cryptocurrency is different. That is digital currency. Okay. So that is different and cryptography is different. Cryptography is basically why we can use whatever communication we are using related to website, especially our application site. It will provide secure way of web communication by using what? By using couple of mathematical calculation or statistical approach or computer algorithms, so that attacker whenever he wants to try to do that, it's very difficult to decipher it. So that is called cryptography. So I'm repeating it once again. So example, maybe Amazon dot India. So it's retail related. Maybe you want to sorry, if you want to, okay, so place any of the order. If you don't use proper, okay, so HTTPS related connectivity in between our web browser to backend server related to Amazon. So by using the cryptography technology, whenever we are making, so example payment, that may be through online payment like net banking, or maybe UPI transaction, or maybe through debit card or credit card. So except cash on delivery, cash on delivery is completely different case. Forget about cash on delivery. So in this scenario, whatever data we are entering starting with the login page 2 till the invoice copy and also placing of the order, everything like a plain text. Okay, so that plain text, whenever attacker can hack our website or application site, you can see entire our data related to PII, nothing but personal identifiable information. And also even whenever we are making the third party payment gateway transaction, so he can take care of our debit card and credit card information as well. So in such a way, attacker will gain the unauthorized access and sensitive data exposure. Now, what is cryptography here? Whatever websites or applications we are using, it can provide secure way of web browsing by using what? By using mathematical calculations and also by using different types of algorithms. By using the algorithms, by using these mathematical calculations or probability or statistical approach, so that we can provide our web security or safe web browsing part. So that is called cryptography. In simple words, if you want to say this one, secure way of web communication is called as a cryptography. For that one, we have to use different types of keys in between our end user to backend server. So in simple words, what is cryptography? Providing secure way of web communication or web browsing, that may for websites or applications. For that one, we have to use couple of whatever scientists developed related to different types of algorithms. Those algorithms may be symmetric algorithms or asymmetric algorithms. So that whenever attacker try to do URL manipulations or parameterized queries entries, input validation related issues, or maybe deface website manipulating part, for those scenarios, automatically attacker cannot hack, even session hijacking or man in the middle attack. So that is the importance of the cryptography. So how we can define this one now? It will provide safe and secure way of web communication using mathematical calculations and also using cryptography using algorithms, computer algorithms. So why we have to use mathematical calculations, I will explain now. What is the reason behind that one? So that attacker, it's very difficult to cipher and decipher the our data. What is cipher and what is decipher? So cipher is like an encrypted mechanism, and decipher is like a decrypted mechanism. So he cannot decipher whatever data we are entering unless otherwise if he doesn't have any keys. So that is called cryptography basically. And the examples of the cryptography technologies. So we have encryption and also decryption. So encryption and decryption will fall under these examples for the cryptography technologies. And every encryption decryption on the end user side and also backend server side, it will use couple of keys. Every system or every end user or every backend server, it will maintain two different types of keys. Those keys are, so several times in the class we discussed this one. One is symmetric, sorry, public key. Second one is private key. So public key, we can share this one. This is also called shared key. We can share that one. And private key, we can also call secret key. Because we have to keep with ourselves. We should not share with other people. So even in our client machine, we can use this public and private key. Even backend server also, it will maintain the public and private key. Already we have seen yesterday about where we can use these SSL-TLS handshake or SSL-TLS mutual authentication, part of the hybrid cryptography. So under the VPN authentication, and also we discussed about RDP connectivity and also web security and even part of email security as well. So these are the different places we can use exchanging of these public and private keys. That is a part of hybrid cryptography. Now, types of cryptography technologies. So there are two types. One is symmetric. Second one is asymmetric. What is symmetric and what is asymmetric? So now we can discuss about these two. So later we can compare about these two. So what is meant by symmetric and what is meant by asymmetric, and additionally even algorithms also we can see. Give me 1 second, guys. Give me hold on a minute. Sorry. Yeah, first we can go with symmetric. What is symmetric cryptography here? So symmetric general meaning is same. So same key we have to use for both encryption and decryption is called as symmetric cryptography. Example, in our practical day-to-day life, if you want to see about symmetric cryptography, our door locking key. So with door locking, we will do same key, and also for unlocking the door also, we'll use same key. For both locking as well as unlocking of our door, we'll use same key. That is the practical example in our day-to-day life. In the same way, for encrypting of the key as well as decrypting of the key, we'll use same key. That type of cryptography technologies we can call it as symmetric. For example, we discussed about endpoint disk encryption or endpoint operating system encryption. So same key we can use for both encryption and decryption. In the similar way, whatever we discussed part of our debit card and credit card download, Aadhaar card download. So all these will fall under the symmetric. So then where asymmetric will come in, two different types of keys can be used for both encryption and decryption. So that is called asymmetric. What are the practical use cases here? VPN authentications, RDP authentication, and website authentication. So even email authentication, WhatsApp authentication. So all these different types of places we can use asymmetric cryptography technologies. One key is for encryption and second is key for decryption. So that is called asymmetric. Okay. So how we can define down this one symmetric? Same key used for both encryption and decryption. is called as symmetric cryptography. So what are the different types of features it will fall under? Before going to that one, examples of these symmetric cryptography: disk encryption, voice encryption, database encryption, except when the end user is accessing. Even file wise we can do encryption. Even we can do, okay, so queries wise, it's completely depending on. So what are the features of the symmetric cryptography? Features now, or advantages otherwise. It will provide only confidentiality, but it will not provide any authenticity or authorization, non-reputation. So why it will not provide authorization? It will not verified by anyone. So there is no third party authority to verify whether, okay, so legitimate user is accessing or illegitimate user accessing. It will not provide any authenticity. It will not provide any authorization. It will not provide any, so non-reputation, traceability side if something it's happened. Okay, whenever if you want to losing the evidences side, all these things can be missed out because of the symmetric. So why? Because here we are not entering any username and password. Only we are entering about the keys only. That too, this for encryption only. We are not providing any additional things like providing the username and password and logging into the system. In the similar client side communication part, additionally, even nobody will verify what type of key are we are entering, like a third party certificate authority or digital signature algorithm. Nobody will verify this one from the backend server side. So that is the drawback. So even it will not provide the any non-reputation part, something it is going to, so getting the legitimate or illegitimate information or honest or false information. Okay, so those things it will missed out, part of the symmetric. So symmetric only it will provide confidentiality. Now what are the drawbacks are available for the symmetric? But only another advantage, it's a faster. Why? Because same key we are using for both encryption and decryption. So that is the reason this is the faster one. So these are the two advantages. And disadvantages, it will use more number of keys for exchanging. So it has formula n into n minus 1 by 2. So this is the based on the what is that, eclipse. So that formula they derived based on the probability. NCR equal to n factorial by n minus r factorial into r factorial. According to that one, scientists they invented this algorithm, and this is also mathematical calculation. So that is the reason even in the our definition also it is showing like a computer algorithm and also mathematical calculation. So this is the way how many keys are exchanged. So this particular thing, it's completely statistics whatever we used or probability whatever we used. So that formula is n into n minus 1 by 2. So that one we studied before 10th standard, like a NCR equals to n factorial by n minus r factorial to r factorial. In the similar NPR equals to n factorial by n minus r factorial. So according to that one, this formula is derived. Okay. So that is about how many number of keys it will use. For example, if you are taking n equals to 100, in that scenario, how many number of keys are required? 100 into 100 minus 1 by 2. So that will come approximate, I think 5050. If I'm correct, I think so. Or 4050, something like that. Okay, so that is about how many number of keys are required for just only 100. Okay. Now additionally, as I said, it will not provide authenticity. It will not provide authorization from the backend server to verify. a legitimate user or not. In the similar way, it will not provide non-reputation as well. So it will provide encryption, that is already we discussed under the confidentiality. So I'll provide additionally encryption also. So that is about symmetric. Now going back to asymmetric side. So here client and server you have to consider. Okay. So now asymmetric cryptography. Here two different types of keys can be used for both encryption and decryption. For example, if you want to log into Unix server. So now we have to provide one of the key also. If you want to make it really encrypted mechanism and without impacting any authentication failure category of the attack. But most of the companies are not doing. What is mean by this one? So for example, so Linux administrator, whenever they are creating any user account or service account for new people or new users, additionally, it's better to generate one private key. And whenever they are trying to access that Unix server, they have to enter username and password. Along with that one, it's better to enter key also. So that is the way we can enter or log into the respective Unix server. Because port number 22 through SSH. So that is not that much. Okay, so that is also one type of risky we can consider. So that is the reason it's better to provide private key as well. So if I want to explain that one practically, so just open the PuTTY application. So PuTTY application can be used to log into the Unix operating system. So example, if I want to give Unix server, here I give 10.10.10.1, that may be Red Hat Enterprise Linux or CentOS or Docker or container or Ubuntu Feroda. So there are different operating systems under the Unix. So port number by default SSH it will appear. And if you want to give the additional key, you have to make it like a connection and authentication. And additionally, we have to provide key also. So anyway, that additionally whatever key we have to enter, that key we have to save it in our either desktop or whatever. So 10.10.10.1, I don't know what is the IP address of the 10.10.10.1. So just I given. So that's why connection will not be established. Yeah, so this is the key we have to give. Whatever key are generated by our Unix team. So this is the way. Additionally, after giving the username and password, we have to give the private key also. Just we have to store that private key, like for example, HashiCorp or Key Vault or KMS. Otherwise, you can store directly in wherever place you like. For example, maybe in your desktop or maybe in the documents or whatever file you like. So then whenever you want to log into the Unix operating system, that key, whatever they generate and given to us, you have to enter that key and later we have to provide the username and password. That is the way how to log into the Unix. But most of the companies are not doing this process. Out of 100% only maybe 60%. Okay, so people are following or 60% companies are following this process. Okay, so that is one of the place. In the similar way, if I want to access any website, okay, so here it means in between my end user web browser to backend server, it will extend the keys related to public key and private key. So exchanging of the keys or security negotiations or handshake can be happen through asymmetric cryptography. Data transfer can be happen through symmetric. Symmetric cryptography can be used for data transfer, and asymmetric cryptography can be used for the key exchanges. Okay, two different types of keys can be used for both encryption and decryption. What is meant by that one? I will explain in a couple of minutes. So example, web security or web browsing otherwise, and also VPN and RDP, email, extra. All these different types of places we can use. Now, what are the advantages of this one here? advantages of asymmetric. It will provide confidentiality because keys are exchanged. It will provide encryption. It will provide authenticity. It will provide authorization, integrity, and finally it will provide non-repetition as well. How that will provide? Give me another 5 minutes, I'll explain. So that is of the advantages of the asymmetric. So this also one of the interview questions. Symmetric is better or asymmetric is better? Obviously, asymmetric cryptography is better as compared to symmetric cryptography. Okay. So now what are the drawbacks? Drawbacks, it is slower. Why? Because so keys will be exchanged in between the end user and also backend server. That is the reason it is slower. And one more advantage also I will provide here. For n number of keys, what is the formula here? 2n. So for example, 100 keys if you want to exchanging, instead of the n, we need 200 only. But in the symmetric wise, we need 5050. But in the asymmetric side, only 200 is fine. So now we can make a comparison between these two in the tabular format. Symmetric cryptography and asymmetric. So same key used for both encryption and decryption. So that is symmetric. Whatever we discussed, okay, so above, same as it is, I'm providing the tabular format so that it is easy for you to understand or differentiate. Two different keys can be used for both encryption and decryption. So that is called asymmetric. Now it will provide confidentiality, but it will provide confidentiality, authenticity, non-repudiation, and authorization also. It is faster. It is slower. And next one, for a number of keys, keys will be exchanged n into n minus 1 by 2. So here for a number of keys, formula equals to 2n. Okay. So it will use out of key band exchange, or this is also called more number of keys. So because as we said, instead of the n place, you can substitute any number and you can see how many number of keys are required. Example, n equals to 10, 10 into 10 minus 1 by 2. So that will come 45. In the similar way, n equals to here on this asymmetric side, you can substitute 10, 2 into 10, 20. So symmetric is required 45 and asymmetric is required only 20. So out of key band exchange means so many number of keys. Here less number of keys are required. Now coming back, it's a very, very important one. Example algorithms are. So several times in the class, I discussed about these algorithms on the symmetric and asymmetric side. So examples are, there are so many, more than 50 algorithms are there part of the symmetric side. To eliminate the drawback on the asymmetric side, around 5 to 6 algorithms. So these algorithms are back and also development. Cryptography algorithm back and development also existing. So RC4. So R is nothing but Rivest. It's one of the scientist name. So the scientist is invented this particular algorithm and he given version number as a 4. Okay. It's so in one of the weakest algorithm, part of the symmetric side. Second one is RC5. So same thing, this one also updated version of the algorithm he invented by Rivest is one of the scientist name once again. Next one, two fish. This algorithm name, blowfish. Yes, correct. Blowfish, Mars, and also we have DES, data encryption standard. AES, advanced encryption standard. And 3AES, 3AES and 3DS. So 3 is the advanced once again more than AES, advanced encryption standard. 3DS. All these are examples for the symmetric side. So in case if you want to use really symmetric side, which one is very, very popular one? We have to use last 4. We should not use weakest algorithms like RC4, RC5. As I said, there are more than 50 algorithms are available. So these are all the couple of examples. Okay. So example TLS 1.0, TLS 1.1. So these are all outdated or legacy. Even SSL 1.0, SSL 2.0, SSL 3.0. It's outdated legacy. Nowadays, whatever HTTPS certificates we are using, SSL is no more. Completely we are depending on the TLS. That to TLS once again 1.2 and 1.3, and latest one is 1.4 also in development state right now. This is also whenever you are running vulnerability management scans on the server side, so inspection also it will do, and it will throw all the certificate related issues as well. Even with the firewall also we have one of the certificate option, security policy or security profile is SSL SSH inspection. Even whenever we are doing the vulnerability management or vulnerability scanning on the host side also, related to all the endpoints or all the servers or all the databases. So all on top of these servers only, we can deploy these SLTLS certificates. So whenever we are running against vulnerability scans on the host side also, even it will throw the respective cryptography algorithm errors. So weak ciphers detected. So TLS version 1.0 is detected. SSL 1.0 is detected. SLTLS certificate cannot be trusted. Okay. So these are the couple of certificate issues also we can see part of the vulnerability management. Okay. So those scenarios, what they have to do, what is mean by that one, all the vulnerabilities on the host side it is reflecting. So they have to upgrade these legacy or older version of the algorithms to newer version of the algorithms. That can be done by our servers team where the ciphers they create. Okay. So in the similar way on the asymmetric side, what are the different types of algorithms will fall under? DSA, yeah, digital signature algorithm. In the similar RSA, RSA is a 3 scientist people they invented this algorithm. Those people names are
Rivest,
yeah, Rivest, Shamir, and Adelman. So these 3 people invented this algorithm. So that's why they given algorithm name is RSA. And one more thing, we have RSA SIM tool also. That is part of the EMC Square and Dell. Previously RSA is separate company. So now EMC Square took over that particular company. So that one we can call it as RSA SIM also. RSA SIM is different. RSA cryptography algorithm is different. So it's a complete legacy now, even that is showing as a Garter quadrant later position. Okay. So that is about RSA algorithm. All these algorithms, bit size, it will support 512, 256, 512, 1024, 2048, and finally 4096 bit size. So that's why these are all strongest algorithms. Coming back, these algorithms, it will support up to 32, 64 or 128 only. So bit size is very, very less. So that is the reason hacker, he can hack easily. All these algorithms are very, very less number of the bit size we can use. Bit size for these algorithms are 16, 32, 48, 64, and 128. Okay. So that is the reason he can guess it easily. And we have other algorithms also. Elgamal, a scientist name. So whatever algorithm he invented, he given directly name to Algamal. In the similar way, we have Diffie-Hellman. DH. It's one of the strongest algorithm. So Diffie-Hellman also scientist name. Next one is ECC, elliptical curve cryptography. Finally, Knapsack. K is a silent letter. Knapsack. So now, if you are using this algorithm, it's the strongest algorithm, and it will not use any. It's difficult to bypass the authorization or authenticity or guess the so what are plain text data we are encrypting. But if you are using these algorithm, more chances are there to break the connection and finally to see about plain text or clear text data, whatever it is traversing in between indus to the backend servers. Okay, so if any certificate you can go and you can see either combination of these three. And one more thing, we can use combinations also. What is combination? So to make sure that which type of algorithms or which type of keys we can use. For example, I'm developer. I will ask one question now. Whether you will give the correct answer or not, I will see. I'm the developer. I don't know what ciphers I want to use or what type of algorithms I have to use. Now, how can you suggest me which type of ciphers we have to use and which type of algorithms I have to use? Anyone?
It will based on the bit numbers and for what purpose we are using.
Okay. Any other? That is fine.
So whenever we want to download or something inside a organization, we can use symmetric because it is faster.
Okay.
So symmetric is for the security purpose we use. So
Okay.
combination we can use.
Yes. But do we have any complaints here? Do you follow any complaints so that you can suggest instead of giving theoretical answer to them? So this is the framework we have to follow. So
We
this
used to use PKI.
not PKI. So I will provide the answer. So whenever any developer or test, whenever any developer, wherever security, I mean certificate is required, if someone will ask what type of ciphers I have to use to configure TLS or SSL or HTTPS, for that one we have one of the framework or one of the complaints. For example, we have discussed about couple of complaints or frameworks already. WASP top 10 is one of the framework. Mitre attack framework, ITL process, NAST framework. Okay, in the similar way, cyber kills process. So these are the couple of process and frameworks already we discussed. In the similar way, to verify the ciphers information, to verify the what type of algorithms we have to use, which one is strongest and which one is weakest, we will use couple of couple of compliances related framework. That framework we can call it a FIPS 140-2. This one we will discuss part of our GRC, governance, risk and compliances. What is the full form of the FIPS 140-2 Federal Information Processing Standard? So all these frameworks also, it's very important, guys. So it will validate, okay, say whether certificate has a weaker encryption or stronger encryption. We can go and we can verify in this website. Okay. So that is called FIPS 140-2 complaints we have to follow. And whenever any developer or whoever, basically they are deploying the certificate and wherever it is required. So we have to follow this website and we can give. So based on this one, we provided the which one is weak ciphers, which one is strong ciphers, and also what is the bit number and combinations also we can use it. Okay, this is the framework or complaints we are not we, almost all the organizations are following. So as I said, what are the frameworks you worked on? It's one of the favorite interview question as well. NIST framework, ITL framework, FIPS 140-2 framework, next one ITL framework, next one so MITRE framework, cyber process. These are the couple of examples for the different types of frameworks. And we have a lot more. Even in the cloud also we have other frameworks also. Even CS benchmark also you can say framework also, that's fine. Like a benchmark, like a baseline. According to this one, we are following and we are implementing in our organization. To verify or to audit which algorithms are strong and weak. So that is about symmetric versus asymmetric. Now we can use combination also. What is mean by combination here? So DES plus Diffie-Hellman plus RSA or 3AS plus ECC plus LGAML. Okay, let's go and see now couple of certificates what our Amazon is using. So www.amazon.india in. Okay, so now where they purchase this certificate from the certificate authority, that certificate authority like a third party here, DigiSet Global. So Amazon India, they purchase this certificate from the certificate authority. That authority name is called as DigiSet Global. Okay. Recently, DigiSet company recruited more than 50 people related to security field in Bangalore location. Okay. So company name is DigiSet Inc. And when the certificate is going to expire and certificate and this is a hash value and here public key. So this key only it will be exchanged in between the web browser of the end user to backend server. Using this key only we will encrypt. For example, if I want to log in here, sign in. So I will enter either my email address or mobile phone number. So now that is a clear text. How that clear text will become encrypted text based on this public key. So this public key can be shared by now Amazon backend server to me, and whatever data I am entering part of either email address or maybe through phone number, using that public key, it will encrypt. Providing the password or key to the plain text or normal text is called as encryption that we discussed several times. So this is my plain text or clear text, my email address and phone number. So now backend server of the Amazon India, it is providing public key to me. Using that public key, I'm entering and I'm providing the password or key so that it will become encrypted text. Now in such a way, this encrypted channel it will form and it will send it to the backend web server of the Amazon. Then backend Amazon web server they have their own private key. So using that private key, it will decrypt what user has sent the data, what user has requested. So then finally, according to that one, it will respond back and it will take appropriate actions. So that is the way how the communication negotiations will happen in between end user client versus to the backend server. Okay. Now, here, whatever keys we are using, that is called encryption, and we are providing all an encryption to provide confidentiality. Now, how it will provide authenticity? Because I'm entering my username and password and OTP number and everything. Providing the username and password is called as authentication. I'm providing authentication. Now, whatever authentication is a public key I entered, and backend server, it will validate by certificate authority, and also backend server, whether he's an authorized user or legalized user, whether his details are existing in the database or not. And also his certificate will be validate digital signature. Okay. So then finally it will provide integrity as well. And authorization also backend server related to Amazon, it can verify by providing grants or permission. If I don't have the account, obviously it will throw an error stating that server side error. So your account is not existing part of the Amazon backend server, please sign up. Okay, so this is the way how the encrypted channel will form, and whenever any type of category of the attack it's happened, we have the proper evidence and logs also. So who is doing what, whether backend server is doing by providing the illegal activity by the attacker, or so whoever is providing authenticity that person is doing, or whoever is manipulating the URL or taking to deface website. So this is the way how the backend web server to the front end end user encrypted communication channel, it will form combination of both symmetric and asymmetric cryptography, that is called public key infrastructure or hybrid cryptography. Okay, go back now. So third one also we have. So I said only two cryptography technologies. Third one also basically that is called hybrid. So most of the case we'll use hybrid only. So now we can discuss about hybrid cryptography. So hybrid cryptography we can call PK, public key infrastructure. So hybrid means a combination of both. So combination of both symmetric and asymmetric cryptography is called as hybrid cryptography now. So what do you mean by here is combination of both symmetric plus asymmetric? So coming back, how this backend process will work related to SSL TLS handshake, part of the hybrid cryptography using symmetric and asymmetric. Okay, now SSL TLS handshake or mutual authentication. So this is what when we were discussing about VPN authentication in between site to site. So I give an example of Bangalore and California, how the negotiation will happen and how the tunnel will form in between the Bangalore and California, same process now. Now we can compare what are we discussed part of the firewall VPN site to site versus SLTLS handshake. Okay. So now take example, this is my web browser. And this is our backend web server. Before going to do that, so first of all, I want to discuss about application three-tier architecture. What is network three-tier architecture? Anyone? What is network three-tier architecture?
Firewall, proxy, and ADSN.
Exactly. Firewall, proxy, NADS, and APS, these three things we can call it as network three-tier architecture. When we discussed about network architecture diagram, there itself I explained about network architecture diagram versus application three-tier architecture. If you are using in our organization level all these three solutions in the perimeter side, those solutions are next generation firewall and also web gateway or proxy server and also NADS and APS. Those three combinations we can call it as network three-tier architecture diagram. What is application three-tier architecture? Okay, so actually I have to provide yesterday that one. I forgot. Give me 1 second.
User layer, business layer, logical layer.
Exactly, that's correct. User layer, business or logical layer, and also backend database layer. Application developers, they will follow this process only. Okay, so here application three-tier architecture. If the application development team, if they're going for any interview, they will ask this question also: what is application three-tier architecture for all the developers and programmers? So first layer is user layer. It's a front end. Wherever input we are providing, wherever input is providing by end user. Okay, so that is user layer. So example, as I said, so this is Amazon. So here I'm providing my input validation, either email address or phone number. It's a front end to me for end user. And after that, I'll provide my password. Okay, so this is the front end side. This is applicable to every application side. Second one, business or logical. So every application developers, they will use different types of programming language for website design or website development or application development. Whenever user is giving the username and password, now it will verify the authenticity, then it will log into the system. So once you are giving username and password, clicking on the login button, so how it will go to next page? Authorization can be done by backend server, and logic, whatever they are creating, it has to log into the next page. And once again, we are clicking on the Amazon and what type of products I need, whether I need electronic items or kitchen items or food items or electrical items and so on. So according to that, whenever you are giving the filter option related to query, automatically all those, it will verify backend SQL database, and front end it will list it. How the application dynamically it is changing from one tab to another tab. So that is called business or logical layer. That is the way how the programmers will develop the code using different types of programming languages. So that is called business or logical. And third one, using different types of programming languages. Finally, backend database, DB layer. So database layer, it will verify the front-end user authentication, authorization, whether is able to access our database or not. That can be done by our database layer. Giving the permissions or grants and everything, that is authorization. So to fetch the any data also. So once you are logging into the system, as per Amazon, as I said, you can fetch the, so whatever items do you want to purchase, how that is possible through SQL queries backend. Okay, it will provide the list of the items. That is the way how the vendor management for purchasing of the application, they will develop the backend developers along with the database team. Okay, so these are all the different types of layer or architecture. It contains application three-tier side. Okay, so now go back to our website related to cryptography, part of hybrid. Why symmetric cryptography we can use? Symmetric cryptography can be used for data transfer. It will not do any security negotiations. It will not exchanging any keys in between our front end user to back end server. Only it can be used for data transfer. What is mean by that one? Example, as I said, if I'm entering the email address or phone number part of Amazon, so that is symmetric. And now encrypting using public key, whatever it is provided backend server, that is called key exchanges in between end user to backend server. That can be done by asymmetric cryptography. Key exchange. What are the different key it will exchange? public key and private keys. So these keys only, if you want to store even our certificates or secrets or password, we have to use couple of tools like KMS, key management system, HashiCorp, and also HSM, and even we have third party tools like CyberArk and so on. So all these things we have to store, and we can rotate, and how many days it is going to expire, everything can be verified part of our key vault and KMS. All these things can be verified. It can keep our keys should be safe and secure. It will safeguard basically. So now we can discuss about same thing whatever Amazon we discussed. So take this one is example of Amazon server. This is front end my web browser. So what I will do first and foremost, if I want to order any, for example, maybe I want to order laptop. First and foremost, I will initiate a connection through HTTP request. So I will go to either Google or directly I will type www.amazon.india. So I'm initiating connection now. Okay. So user will initiate the connection. So by providing the URL link or website name. So that is the first thing. Later what it will do, so if you want to log in, so obviously we have to log in into this one, then only I can order. Otherwise it's not possible to so order anything unless otherwise if you don't have the account. For that one we have to do the registration or sign up. Anyway, I complete sign up and registration and everything. Now I want to place couple of order. Okay, related to laptop for example. So now I logged in and I have the account. So once I'm giving or logged in into what Amazon backend server will provide, part of the second step, it will send public key because here it is two keys and also here it is two keys. Every end user machine or every device can maintain two keys. So public key only we can share with other people. That's why it's called shared key. So but private key we cannot share it. Is a so secret key. Now Amazon it will send back to backend server. It will share public key with the front end user. So that is the second step. Now third step, what exactly it will do? Whatever symmetric keys I'm entering, for example, here I'm entering my clear text and plain text data. So for this one, it will use symmetric keys for data transfer. So that where the data can be stored, it can be encrypted using that private key. Okay. Symmetric keys can be used for data transfer. Now, whatever second step it is provided by the backend web server, so that public key I have to take. Using that public key, I have to encrypt the data. End user will take the public key of the backend server and it will encrypt the data of symmetric, and in such a way encrypted channel will form. Now already Amazon backend server has a one private key. Using that key, backend server has its own private key. using that key, it will decrypt the data, and also according to the end user request, it will respond back, or it will take appropriate actions. So that is the way overall how the TLS and SSL negotiations or handshake will happen. Now I have one question: whether all this process is correct? Whether all the process is correct? Yes, it is correct. But is there any problem or anywhere is there any issue except Ramesh? In these all these steps, is there anywhere, any place, is there any drawback or disadvantage existing? Can you try it? In case if is there any drawback or disadvantage, what is the drawback or what is the disadvantage? Then how can we rectify? Anyone? Otherwise, which step? 1, 2, 3, 4, 5. For example, 5 steps. Which step has a issue? Whether 1 or 2 or 3 or 4 or 5. Anyone just guess?
3.
No? 3. What is the 3 issue here? Is it Reshma? No
Yes,
problem.
sir.
Yeah, Reshma, can you explain why it is a drawback? Just whatever you know, just you can say, that's fine.
No, sir. I simply guessed that it is 3. That's
Okay, that's fine.
I think
Any,
it's
any
or
other?
it's 2. I think so. 2.
2. Why it's 2? Yes, 2 is correct answer. That's correct. So 2 is the correct one. So backend server will share public key with the front end user. We don't know whether really Amazon backend server is sending public key to us, or so maybe on behalf of the Amazon backend server, attacker is sending. So for example, whenever you are you have taken already Amazon.India and you are clicking on the login button. So on the top you can see, I'm going back once again. So right now HTTPS Amazon India, and if I'm clicking on the login button on the top, JW token, it will change. Initially whatever token it is there, and it will redirect to some other login page. Maybe attacker can take the token initially whatever Amazon.India it is there, and it will redirect to deface or fake website. With 400 or 500 or 1000 rupees, I can purchase one of the domain. Instead of the Amazon India, maybe I can provide Amazon IND. I can purchase for the domain as I am Amazon IND. Whenever someone is placing the order, whether they will go on, they will verify all these, what is the URL link it is existing, whether really from the attacker, and whether it is coming from the end user or attacker. All these normal people, they don't know, they know about all these technical things. They know only one thing. So whether we are ordering our item or not, whether it is placing the order or not, whether it is coming the receipt or not. So one is the delivery date. So that's what people will think. So before, okay, so logging into this normal website, and when I'm clicking on the sign in button, so that time maybe attacker can take URL manipulation, or maybe URL redirection, or maybe session hijacking to his particular deface website. He can create same as it is in such a way it looks like similar way of the website. Okay, so that is the reason what we have to eliminate this drawback. So we have to use anyone. What we have to use to eliminate this drawback? SSL TLS purchased CS certificate from third party, so that it is legitimate. It's not from the attacker. Okay, so second step is a drawback here. So we don't know whether really this backend public key is sent by the end user or from the legitimate server. Okay, so to eliminate this drawback, now what we have to do? We have to purchase SLTLS certificate from third party. So third party, whatever certified authority we are purchasing, that one we have to deploy in on top of the server. Now server will validate. So whether it's legitimate or illegitimate user. So now go back to our website and click on the so connection is secure and certificate side. Now you can go and you can see. In case attacker is purchased this SLTLS certificate for amazon.ind domain. So here we can see Amazon IND. We cannot see www.amazon.in. www.amazon.in is a legitimate website from the vendor directly. So I can go and I can create fake website also. Instead of IN, I can create IND IA India or maybe IND. So this is the way how we can make sure that certificate should be trusted one. And additionally, after providing my username and password, digital it will validate along with credentials by backend. So this certificate where it is deployed on top of the web server. Okay. So that is the way how we can verify. So this one, it contains digital signature algorithm also. That's digital signature algorithm part of hashing algorithm. Okay. That hashing algorithm here. SHA-256. SHA-256 is a hashing algorithm. You can see certificate signature algorithm, certificate signature value, SHA-256. So this is the signature algorithm. It is using SHA-256 signature algorithm. For the attacker side, it will not be same signature. It can be used. So first of all, you will not purchase also. Just you can create dummy website. You will not purchase that certificate or just you can create fake website with, as I said, by providing the domain. And also we can see instead of the HTTP, yes, we can see HTTP. It is redirecting to attacker. So that is the reason whenever you are accessing any website, so please verify whether it is going legitimate website, that redirection, or it is going illegitimate related to HTTP. So for example, I'll give practical scenario. So once I was booking orange travels from Vijayawada to Bangalore. I was traveling. So that time, so I provided my so date and time when I was traveling, what is the departure time, everything I selected. So I provided my email address and I provided my name and also I provided seat number and everything. I given the next button. So later it is redirected to the fake website. The attacker already took my details and the payment gateway went to third party. Even Orange Travels doesn't have the HTTPS. Orange has HTTP. So 2 years back, I think. So now, then I called customer support of the Orange Travels. Why you are utilizing HTTP? Why not HTTPS? Don't you have certificate? I given complaint to service desk team. Later, immediately they changed from HTTPS to HTTPS. Not only this one, I have changed so many websites same way. Whenever I will identify either HTTP or HTTPS, so that it's not only useful for me, so it will for other people as well, right? Otherwise, people will lose their money. In case attacker is making redirect to some other third party. Same thing whenever I select a Hawaii company from China-based telecommunication company. I selected and also they thought to release my offer letter and they provided one of the URL link. There I have to upload all of my educational certificates and also salary slips and Form 16 and PF account, everything I have to upload. When I was checking, so careers dot so hawaii.com, it is showing HTTP instead of HTTPS. So then immediately I have sent an HR recruiter. His name is Chiranjeev Reddy. So then why you are using HTTP? There are all over the worldwide. So many people, they will use this Hawaii placement. Whenever they are selecting, they will enter their PIA data related to GDPR compliance. Within 30 minutes of the time period, that website, they made it like from HTTP or HTTPS. It's not only useful for myself. In case attacker will compromise this website, so whoever is entering their recruitment site, obviously they have educational documents, they have their salary slips, they have their so Form 16s or PF accounts and so on. All the data we are entering into that portal. Then only they will release the offer letter, right? All of our PI data should be compromised. I can give complaint on the Hawaii now, but I did not do that. I can complaint directly company that I have evidence also. Then immediately within the 1 hour time period, so they changed that one to HTTPS. So this is the way whenever you are trying to access any website, please try to check that one, whether it is a plain text or clear text data they are trying to use, or whether they are completely HTTPS, and what is the legitimate website, whether they have certificate or not, and what is the domain they purchased, whether it's a legitimate domain or illegitimate domain. For any website I used to access, normally I'll verify everything. Then only I can go and I can access those websites. But anyways, we know we are security. We can go and we can do all this in-depth analysis. What about, okay, so without security knowledge people, they can go and they can place the orders. That is the reason a lot of issues are happening and a lot of hacking is happening and people are losing the money. Okay, so that is anyways. Going forward, okay, please educate, as I said several times, giving the awareness by downloading some of the apps from the Google Play Store, or maybe accessing any website in the laptop or mobile also. Okay, please keep yourself at least safe and secure. Otherwise, your data also you can lose it. Okay. So yeah, coming back here, hashing algorithm it will use so that it will provide integrity of the end user also. So this is the way how we can verify all these things. So version here, what is the version of the, here it is TLS 1.3. Version of the certificate TLS 1. It's fine. It is a symmetric complete algorithms also. Somewhere it will be there. 1 second. Yeah, you can see PKCS. It's a PKCS file name. It's a PLM category of the file. So normally we have .doc, .exe, .csv, .excel, and so on. Correct? In the similar way, certificate whatever we are purchasing from the self-signed or purchased CS certificate, it's a PKCS format. SHA-256 is one of the strongest hashing algorithm. MD5 and SHA-1 is weakest. It will maintain the integrity of the end user. And with RSA encryption, it's asymmetric cryptography with 4096. That is the latest version. So obviously it is everything is like encryption and confidentiality, authentication, authorization, integrity also verified. So that is the reason we have to use these certificates to make sure that everything should be safe and secure. Otherwise, so end users can lose the data or end users can lose the money. Okay. Drawback. For above process, second step, we don't know whether the end user is sending the data or sending the whether backend server is providing public key to end user or attacker is sending. To eliminate this drawback, we have to use SSL TLS certificates with strong hashing algorithm, with strong encryption, with the latest version of the TLS. And also it's a digitally certified. And also certificate should be digitally certified. So that is about drawback. Okay. Now certificates maybe I will explain tomorrow. So I will start one more, integrity. Even though we discussed about confidentiality, integrity, and availability, part of our basic definitions. So integrity is not completed yet. Okay, so integrity we have to discuss about in-depth analysis. So why we have to discuss about in-depth analysis? We should know about what are the different types of hashing algorithms, on how the certificate should be digitally certified, and what are the different types of HMAC or hashing algorithm types, and what is my digital signature. Everything will fall under the integrity. Okay, so that we can discuss integrity in-depth analysis. What is integrity, guys? Anyone? What is integrity?
Data cannot be modified or altered.
Trustworthy of the data or secrecy of the data.
The trustworthy of the data, secrecy of the data, or someone should not add or delete or modify the data. He is nothing but unauthorized user. So that is called integrity. Okay, that's correct. Or unauthorized attacker or end user should not add or delete or modify or changes the data. So that is called integrity. So how integrity can be measured? Anyone? How integrity can be measured? Based on
Hash value and checksums.
exactly hash value. That's correct. Now, whether data can be modified and how many ways? Data can be modified. For example, if I'm giving cybersecurity material document to everyone as an edit option, what will happen?
Data always will be changed by all the people.
Yeah, maybe because of the knowingly or unknowingly, intentionally or unintentionally, or maybe because of the typo issues. This content, whatever I'm typing, maybe it will change. Okay, so data can be modified knowingly or unknowingly, with the knowledge or without knowledge. Or intentionally, wantedly, people will do. That is like attackers. So this is the way data can be modified. Okay, now integrity is depending on several parameters. So what are those parameters? Integrity is depending on several parameters. Those parameters are: first one, hashing algorithms; second one, HMAC; third one, anyone? Already we discussed. In the SLTLS certificate, we discussed digital certificates. So these are the three different types of things. It is depending on hashing algorithm, and also it is depending on HMAC, and also it is depending on digital certificates. So now we can discuss about these three in-depth analysis. So first, hashing algorithm. Before going to hashing algorithm, what is my hashing? As per the file oriented in our concept,
It is
a
the
digital representation of the file. That's correct. File is called as hashing. So what is mean by this one? Example, go to virustotal.com. See, I access to virus T is missing here. That way showing as a risky. So one of the file I'm uploading, confirm upload. So these things, whatever right now I'm uploading in the open source, same thing can be done by our EDR sandboxing tool and firewall sandboxing tool also. Okay. So this is the way how the files can be analyzed within the fraction of less than 1 minute. And it will give the verdict by, so our vendors, whatever we are using. We have seen one of the profile, antivirus profile under the FortiGate firewall. In the similar way, EDR tool also have the threat prevention profile. So these tools has by default inbuilt so analyzing capability and sandboxing environment from the vendor itself. So that is the way how these files can say verdict whenever any file is analyzed by the vendor tools. And within the less than 1 minute of the fraction of the seconds, it say whether the file is legitimate or illegitimate. Okay. Nowadays, already by default, EDR and XDR tools, whatever we are using part of the malware analysis, it is integrated. There is no need to come manually, and there is no need to upload all these files through manual way. If it is required really to upload the files in manual way, then we have to create our own sandboxing environment or testing environment in our organization for malware analysis side. Still, if you don't know whether the file has infection is existing or not, then we have to raise a case with the vendor and vendor take the vendor support. So this is the way how to do the overall analysis side. Okay, go back here. Now out of 63 vendors, whatever file I uploaded, it is showing no vendor, it does not contain any malware. Verdict is a fine, it's a legitimate file. Okay, now go to details here. And before going to details, you can see, so this is my hashing algorithm. So hashing algorithm is this one, digital representation of the file, not analog or not physical hard copy. So this digital representation of the file, we can call it as hashing algorithm or hashing. Combination of both characters and also numbers, alphabetical and numbers, is called as hashing. So there are three different hashing algorithms. You can see MD5, SHA-1 and SHA-256. So MD5 and SHA-1 is already outdated or legacy, and we should not use this one. Even whenever you are doing the malware analysis using EDR tool, or else maybe SIM tool using SOC operations side, don't go with MD5 and SHA-1. Take SHA-256 hash value and do the analysis side. Okay. So that is called hashing. And next one is hashing algorithm. So there are three different hashing algorithms already, we know. Those hashing algorithms are, what is first one? MD5, message digest full form. Second one, SHA-1.
Secure hashing.
Yeah. Next one is SHA-256. So these two are legacy. So before going to that one, it's a 128 bit. It's a 140 bit. And this one is 256 bit. So now these two are legacy, are old, are outdated. So strongest hashing algorithm is SHA-256. So these are the hashing algorithms. So if you want to analyze the file or someone is changed file content or modify, and for tracing purpose, we can check the repetition of the hash value also. Second, HMAC. What is MAC? What is MAC?
Control.
Media access control. Where we
Media
discuss
access.
this concept.
Layer 2.
Layer 2 part of data link layer. So one of the sub layers under the data link layer. There are two sub layers under the data link layer. One is LLC, logical link control. Second one is media access control.
Media
And also,
access.
yeah, physical address also called as a MAC address. Those places we discussed about MAC. So here,
Right.
hash message authentication code full form. So what exactly this one will represent? Body of the content of the file. If someone is changing or whether integrity will change or not.
Yes.
Yes, it will. Yeah, body of the content of the file can be represented using HMAC. Okay. So as I said, in this file, whatever I'm giving overall content of the file, someone is modified. So automatically it will change the content of your body, whatever I'm entering of the data. Okay. So that is called HMAC. So think like you are sending one of the email, or think like one of the file you are uploading or downloading, or maybe you are changing the data, or you are modifying the data. This is not only applicable to file oriented, even some of the developers are making the code. That code they are changing or updating or deleting or modifying. Part of the logic bomb category of the attack or malware category of the attack. Okay. So third one is digital signature. So digital signature can be verified by the end user to check the identity of the end user. For example, I think till August 31st or July 31st, I think, sorry, everyone is filed income tax. How the government of India can verify whether really legitimate user is verified or not? Based on what parameter?
Digital signature.
Exactly, digital signature. We have to open the file and we have to click on the digital certificate file and we have to verify our identity. So that some X company this user is working on, then automatically our signature can be verified based on the cryptography algorithms, whatever we used, or hashing algorithms, whatever we used. So that is one of the place. In the similar way, even Aadhaar card also sometimes we have to verify. Wherever it is required, if you want to verify the digital signature, that is nothing but identity of the user, integrity of the user, whether legitimate user has done or unauthorized attacker has done. So that is the way how we can verify our digital signatures. Okay. Give me 1 second. 1 second. Sorry, guys. Yeah, digital signature is depending on SLTLS certificates. And also integrity of the end user or identity of the end user. So that is about overall integrity now. So now think before going to SLTLS certificates we can discuss once again tomorrow. So last topic for the integrity side, before going to SLTLS certificate, part of our digital signature. Then we can discuss some versions of the SLTLS. So first we can go with SSL. Secure socket layer. So secure socket layer, and what is the port number?
443.
Exactly 443. So here secure socket layer, and there are 3 different types of versions under the SSL.
1.1.
SSL 1.0 or 1.0. So second one is SSL 2.0. Third one, SSL, yeah, SSL 3.0 or 3.0. So in case if you are using these 3, all are legacy and old. All these 3. It's outdated one. But initially it is given name as SL or TLS. So same thing are continuing. Basically we have to use TLS security instead of SSL TLS. It's a legacy or old or outdated. In case if you are using these things in our SLTLS certificates, couple of attacks will fall under. Not because it is weak ciphers. If you are using weak ciphers, sorry, if you are using legacy versions of the SSL, we will get the attacks like hard to bleed.
Authentication, right?
Hard to bleed, sorry,
We'll get authentication kind of errors.
not authentication kind of error. So attacker can do. So what type of different types of attacks if you are using weak ciphers? Hard to bleed, he can try to do that. Second one is Sweet 32 vulnerability or attack. So third one, Poodle attack. Did we discuss all these attacks?
No.
No, we did not discuss. That's correct.
OS.
Yeah, hard to bleed. It's a part of basically if you're using legacy versions of the SSL 1.0, 2.0, 3.0, attacker can try to do either URL manipulations or redirections, or maybe taking to some other websites like a deface or fake. Then he can gain the unauthorized access sensitive data exposure. Then what is Poodle Sweet 32? If you are using weak ciphers, part of the SSL TLS certificates. So then we can get the Sweet 32 vulnerability once we are running on the SSL TLS inspection. So, and finally attacker will gain the, so what a plain text data we are sending part of the encrypted channel. Third one, Poodle attack. So padding Oracle on D. What is D? Data legacy encryption. Padding Oracle on a data legacy encryption. It's a legacy encryption. It is strong encryption. It is not a strong encryption. It's a weak encryption, or it will use weak ciphers. So attacker will gain the unauthorized access or sensitive data exposure or plain text data related to PI or PHI or any confidential data you can see. So that is called Poodle. So why they mentioned the Oracle? Why not some other database, or why not some other application? Initially, yeah, initially attacker is identified and hacked this particular attack on the Oracle side. So that is the reason that attack, it has given name as a Poodle attack. Padding Oracle on data legacy encryption. Okay, so these are all the attacks. And one more attack, not because of the SSL, because of the hashing. Here. Birthday attack. Now I have one question here. Every file has the same hash value or 2 different hash value?
Unique cache value generally.
Yes. In case someone will change the data or modify the data?
You will have
Value
unique.
will be changed.
Yeah. So whether 2 files have the same hash value?
In MD5, there was actually, that is the drawback of MD5.
Yes, that's correct. So whether 2 files have the same hash value?
Collision happens, right?
Exactly, that's
Okay.
correct. Collisions will occur or conflicts will occur. That collisions are conflicts only we can call it a birthday attack. That is a drawback of the MD5. That's correct. Okay. So in case two files has same hash value, collisions or conflicts will occur. So that attack is called as
Birthday attack or
yes.
collision attack.
So to mitigate this one, what we have to do now?
Use stronger algorithms like SHA-256.
Exactly, that's correct. So mitigation, we have to use strongest algorithm.
In this, actually, MD5, since the bit is 128, two different files also, which has 128 bit, this occurs, right?
Yes, yeah, even 128 bit, yes, it will occur. Oh. So in the entire conversation water we discussed in this class, all these topics are very, very important, guys. So now, so attacks I can provide later. So these attacks. Next one is the TLS versions. So TLS versions are TLS 1.0.
1.1.
In case in the vulnerability management, if I don't provide these vulnerability names, I'm not sure whether I provided or not. Let me go and verify. These are all important things as well. I don't think I provided. Example vulnerability names. Legacy versions only we provided, I think. Kernel update, OpenJDK Java. Okay, rsyslog. It's not there. So I will add those three also. Maybe I given here. Suite 32 portal outdated version. Okay. So I'll add the two more as well. SSL TLS cannot be trusted. What is meant by that one? Anyone? What is by SSL TLS cannot be trusted?
If it is not from a licensed vendor.
Exactly, that's correct. It's not from certificate authority vendor. So it is like our own certificate and we are using for publicly exposing websites. So that is called SSL-TLS certificate cannot be trusted. And outdated SSL version, no, I will provide here.
Sir, validity will be expired, then also will be considered as a cannot be trusted.
Yeah, even yes, cannot be trusted. So that is the reason we have to do the so certificate rotation also, renewal of the certificate. We have to monitor the certificates also. Okay. So before going to expiry, so at least for 10 days before, not 10 days, not even 10 days, 1 month before itself, we have to get the notification and we have to try to purchase and we have to renew it as soon as possible. Okay, go back to application security now. TLS versions are TLS 1.0, TLS 2.0, sorry, TLS 1.1,
1.2 and 1.3.
yes, TLS 1.2 and TLS 1.3. Right now, TLS 1.4 in beta version meaning here like a development environment, testing environment. Once they succeeded successfully, then they release to the public. So couple of times in the vulnerability management and application scans yesterday, what we discussed the related third party software scans. We can identify these versions issues as well. Okay. So then you have to inform to your developers or testers or OS team stating that please upgrade these ciphers or versions of the certificates, whatever we are using. Okay. So that's all for today evening. Can you attend tomorrow class morning?
Sure, fine.
Sure, sir.
Around 9 o'clock, 9 a.m.
Okay.
What about others? Because we are lagging too much, that's why. And moreover, I'm going for too much in-depth analysis for your batch, especially. So we need more classes. And I have to cover cloud security also. Because for previous batches, I did not cover any cloud security. Just I did not give not even cloud basics also.
And also the preparation is also very difficult to all this with all this stuff. Very much
Yeah.
depth subject you are giving.
Yes.
Dedicatedly, if you are going to one side, then it will be very fine. But if you want to cover all those topics or all those in security types, it will very difficult.
Yeah, that's correct. So you are right. So that is the reason. Don't go with all the security technologies. You can choose out of 6 whatever I'm going to teach. So either maybe 3 or 4. So then in the 3 or 4 only you can choose and you can attend the interviews. But you can try that one also, just for to get the practice, what type of questions they are expecting, how the interviews looks like. Okay, really Ramesh is giving good feedback. So choose whatever you like, and according to that one you can mold up, and also even you can attend those interviews as well. But so you will get some of the experience, how the market should be look like, and what type of questions they are expecting from us. Okay.
Exposure to market.
Yes, correct.
So, IIM comes under which domain exactly?
IIM is a part of basically it's a separate
Active
technology. I cannot say I cannot say under specific to one domain.
Okay.
I can say this may be cloud and infra both.
Okay, fine.
Cloud security and infra security, part of Active Directory and Cloud Azure Active Directory in such a way. Yeah. And also I can say this one IAM Zero Trust Network Access as ZTN. It's one of the trending technology. So it will cover under ZTNA as well.
Okay.
Yeah. Okay, then tomorrow morning I will take the class, and coming Saturday and Sunday, let me verify whether I will be traveling or I will be here. In case I'll be here, I will take the market is compulsory. Okay. And by the by, whatever videos I'm sharing in the YouTube, are you checking those interview questions?